Our speakers on the stage will be Csaba Gecse and Zsófia Sa. Csaba is a software development manager at Tesco Technology. Throughout his career, he has gained broad experience across various business domains. His work is focused on building scalable platforms and optimizing development flow. Beyond his professional life, Csaba is passionate about smart home technologies, IoT, psychology, and exploring the intersection between technology and human behavior. Zsófia is a product manager at Tesco Technology, where she spent the past 1.5 years, starting as a fresh graduate, working across 3 teams to tackle a range of back-end, front-end, and data science challenges. With experience in both internal and customer-facing products, she's passionate about spotting impactful opportunities and creating solutions that make life easier while balancing business needs with technical feasibility. The title of the talk: Solving the Documentation Problem in a Large Enterprise, a journey from static documentation to generative AI. Please welcome on stage with a huge round of applause, Csaba Gecse and Zsófia Sa.
Good afternoon, everyone. So before we start, let me ask a quick question. When was the last time you read documentation that was up-to-date, easy to navigate, and actually help you with your question? Just raise your hands. This week? Lucky you. This month? Nice, nice. Maybe this year? Okay. And do you struggle to remember? No? Okay. Then welcome to our talk. We are very excited to talk to you about today one of the most persistent yet underestimated challenges that large organizations face, and this is documentation. We will show you how generative AI can provide a completely new lens to tackle this problem. But before we dive in, let us briefly introduce ourselves. I'm Zsófia Sa, graduate product manager at Tesco Technology for a little bit over 1.5 years. And I spent the last 6 months working closely with Csaba and his team on the initiative that we will share with you today.
Hey everyone, my name is Csaba Gecse. I'm software development manager in Tesco Technology, and welcome to our talk. So just a short agenda what we are going to talk about today. So we would like to start with the problem statement, why we are doing all this, and we would like to present on evolution, the journey itself, how we arrive at the generative AI solution. And we would like to go into details on the generative AI solution just to understand what we did and how it works.
Okay, so let's start with the most obvious question ever. Why we decided to use generative AI? So as all of you probably know, AI has a lot of use cases, and we are currently utilizing a few of them at Tesco. For example, we have meeting and pull request summarization, coding and testing assistance, content creation and branding for marketing purposes, and now brand new chatbot for accessing internal knowledge as well. AI has a lot of benefits, but before I would go too far ahead, let me take a step back and start at the beginning. So every similar journey starts with a problem, or rather an opportunity, depending on how you view it. We prefer to talk about opportunities, so let's see what was ours. I think everyone here has experience with the headache that documentation can cause, especially if you work in a large company, where documentation is scattered across multiple platforms, it's updated manually and inconsistently, and this results in a lot of duplicates being created with conflicting information. And actually, in our latest developer experience surveys, we learned that 60% of our developers are wasting time regularly searching for documentation, and out of these, 15% waste more than 3 hours a month doing this. And why this might not seem significant at first, if you multiply it by the hundreds of engineers we have, the cumulative impact is quite substantial. And just to put it to context for you, I will give you some numbers. So in Tesco we have 284 tech teams with around 2,500 developers in them, who are all contribute to documentation in some shape or form. of course in their choice of 10 plus systems with 10 plus integration methods. So as you can imagine, keeping this base clean and up to date is a big challenge. To understand it a little better, let's visualize a common workflow or scenario. Let's say that you are a developer who's in need for some documentation. So you will start by browsing through a lot of platforms and systems like Jira, Confluence, GitHub READMEs, internal wikis, SharePoints to find what you need and try to put the pieces together. And if you've ever been in this situation, I think you have experienced with the frustration that browsing through semi-relevant results and duplicates can cause, and you usually find yourself reaching out to the owner teams for more support. But let's say you finally locate a document that you think you need, and you will shortly be faced with a lengthy content with a lot of details, which is actually a good thing, but not for you this time, because you need a very specific information to complete your very specific task. So you try to look through the document, understand the structure, find the relevant piece, and even if it's the right document that you find, there's still a risk that it's outdated or incomplete, or the details in it is not relevant for your use case. So you find yourself once again reaching out to the owner team, wasting both your and theirs time on unnecessary exchanges. So when we mapped this out and actually realized these pain points and the impact that we could have if we do something about it, we decided to act. Our initial goal was to solve the documentation fragmentation problem by creating a single source of truth. And it sounds quite easy. And we took an iterative approach, we gathered a lot of feedbacks, we learned through trial and error, and there was a lot of errors in our story. So allow me to walk you through at the initial phases of our journey. So at first, we envisioned having static pages for documentation hosted in our internal developer portal. And this idea actually was quite popular. A lot of teams were reaching out to us for their documentation to be hosted on our site. However, we quickly encountered a lot of technical and operational challenges because we were the ones who were mapping and structuring and also maintaining the documentation manually. And it turned out to be very time-consuming for even one single team. So we quickly realized that this solution was not scalable at a pace that we would want it to, and we need to change strategies. And this is how we arrived to our second phase and introduced our Knowledge Hub, where instead of static pages, we thought that we would just simply link to high-quality resources, and out of those links we created searchable categories. And we have very high hopes for these solutions. However, initial user feedback identified or highlighted quite significant shortcomings. Firstly, adoption was way lower than we anticipated it to be, and also existing users were complaining about inefficient search capabilities. And what you need to know about this search engine was that it was heavily reliant on the category names and indexes manually assigned again to them. And as you can imagine, to have an index base that is actually usable for everyone within Tesco was quite a big challenge. So this was the second time where the manual approach proved to be inefficient for us. So we decided to take a step back, start again once again, and completely rethink how we approach the whole problem. So here we are again, back at square one, where we started to think, brainstorm and research once again, and we quickly realized that we needed to change how we think about documentation and started to reimagine it as something dynamically changing, similar to code itself. And we realized that our focus should have been on the continuous knowledge capture and as precise retrieval as possible. And of course, new researches among developers that were highlighted that AI-driven tools are proved to be and recognized as the most efficient way to complete or do coding, testing, documentation, and also knowledge retrieval are the most popular ones. So with this new knowledge, we decided to turn to generative AI ourselves. We imagined having a conversational interface where developers could just ask their questions naturally how they would with their colleagues. And in addition, this solution would allow unlimited follow-up questions as well, meaning that we would save time for the knowledge owners too. And of course, since it's AI, it would have a lot of other benefits. It would be personalized. It would have a contextual understanding based on your individual chat history, meaning that you would get an answer tailored to your needs. And also in an ideal scenario, it could reduce cognitive load as well, since you just get the answer from one single tool, you don't need to look anywhere else. But of course, with all of these benefits, there's a lot of new concerns and challenges that we needed to tackle as well. For example, how would we build trust? So our developers would actually adopt and use the chatbot. How would we guide them and onboard them so they know how and for what to use it? And of course, on the technical side, we needed to prepare for failures and also needed to minimize the risk of hallucination and biases. And Csaba will tell you all about these concerns a little bit more in depth while he talks about the technical aspects of building our chatbot.
Thank you, Zsófi. So as Zsófi mentioned, generative AI is becoming widely adopted, so that's why we also decided to start a POC, and we wanted something with large language model capabilities with the flexibility of adding new content. So that's how we arrived at the retrieval augmented generation, RAG in short, and the initial results were really good. But what does RAG mean? So RAG means there is a magic component somewhere which is responsible for generating the output, and it can work some additional context coming from somewhere else. But how does that magic work? So let's quickly go through the conceptual building blocks of a RAG solution. So large language models, or LLMs, are responsible for generating natural language content by predicting the upcoming words in a sentence, and LLMs are really good at that task. Embedding models are responsible for creating vector representation or mathematical representation of the contextual information we have and we want to handle. But why do we need that? Because that's how we can store that contextual information in vector databases. And basically we can retrieve search operations later on the vector database just to search for that contextual information and work with it. Prompts are used to control how the RAG is working. So prompts are controlling the search operations and the answering operations in a RAG setup. So this is a standard, but what's the big deal here? The big deal here is to integrate our RAG solution with the existing documentation platforms we use in Tesco. So just to understand how RAG works, let's quickly go through a typical RAG architecture. This is a high-level conceptual diagram, of course, so in detail it's a bit more complicated, but this simplified view, I think, gives an understanding. So on one end, we are sending in documents, and those documents are taken by document processors, and those document processors are responsible for transforming the documents on desired format for further processing in the RAG pipeline. On the other end, the users are sending in questions and the LLM answers. But what questions can the LLM answer? So LLMs are pre-trained models, and the training happened using lots of text produced by humanity over time. So it can answer questions related to the information it knows, but at this point it doesn't know much about Tesco documentation. How can we extend that knowledge? So that's how the embedding models come in picture. So the embedding models are responsible for creating the vector representation of the context we want to store or we want to use. So, for instance, when a user is asking a cat-related question, the embedding model is creating the vector representation of that question, and it's trying to search any document chunk which is stored in the database already that are related to cats. The vector search itself works in a way for finding semantical meaning. So in a natural language conversation scenario, we don't want exact textual match, but we want semantical match. So that's why we use vectors, and that's how vectors come in place. So as you can see, we have a few vectors stored in the database. Each number of this vector represents a certain attribute of the related phenomenon. So for instance, 0.8 can mean it's a living creature, 0.29 can mean it has 4 legs, and there are other attributes as well. So once we have the cat-related chunks, those cat-related chunks are augmenting the LLM context. In other words, they are extending the LLM knowledge, and that's how the LLM can answer the cat-related question. Okay, Zsófia mentioned already a few challenges and considerations, so let's just quickly review those. So how can we make sure that our answers are reliable? So we have to have something in place with which we can measure answer quality. How can we handle hallucinations and biases? So like every neural network, LLMs are also working with probabilities. It means that we have chances for incorrect or not relevant, sometimes incorrect and not relevant information in the context. And what we can do with this, we need to change the controlling factors to minimize that chance. When we speak about security, the main question is how can we make sure that our information is safe in the LLM context. So you can think about any detail like trim private documentation, personal details, connection details of a remote API, whatever. Observability is also an important factor. How can we use regular observability patterns or even more in an LLM or RAG context? How can we make sure that the incoming information is relevant and it helps answering the questions? So here we decided to govern the information onboarding. So we are providing standard ways how the knowledge can be added to the chatbot. And also we decided to control the RAG settings. So we are not delegating those to our users. What if something unexpected happens? So we have to be prepared because the chatbot is talking to users who don't want to see long stack traces or esoteric error messages. And one of the most important questions, how can we manage cost? How do we make sure that we don't bankrupt the company? Okay, I would like to just briefly address a few of these concerns, starting with security. So when we are talking about RAG security, we need to consider a bit different aspects compared to traditional IT systems. So, for instance, the chatbot is talking to human beings, and there is no other human supervision is present in that conversation. So people may have intent to talk about unwanted topics like violence or something similarly malicious, and the chatbot must be able to detect those attempts, and it must be able to intervene immediately just to maintain the psychological safety of the conversation. So how can we implement that? We can build in guardrails in the process. Those can be part of the prompt of the LLM, or those can be implemented in an upper layer of the solution. So we can protect the LLM from falling into the trap of those conversations. The other very common and very popular kind of attack against chatbots is the system prompt injection. So what system prompt injection makes with the chatbot is altering its behavior. So imagine if someone could just override it, then you would get a completely different chatbot experience. Even you would say it's not even your chatbot anymore. So we need to build in safety measures that prevent the system prompt injection. Similar solutions we can apply here, so we can implement additional layers in the architecture, and also the LLM itself is able to detect system prompt injections if we have proper setup in the related environment. I briefly mentioned how we can protect, or how we should protect the details of connected services and private information. So, as we mentioned, the LLM is talking about the context which it has already. So, an information is present in the LLM context, it will be revealed at some point. So, we need to make sure that the information which is getting to the LLM context is controlled. We can implement role-based access control in the data layer, for instance, and yeah, that's it. So, pen tests. Just like every traditional IT system, pen tests are important in case of chatbot as well, because these pen tests, they are running in a bit different way compared to traditional IT systems, but these pen tests can help us discovering the issues with the previous points we discussed. Okay, next important factor is cost. So how can we make sure we don't bankrupt the company? The answer is simple and complicated at the same time. So first we need to understand how language models generate cost. So the fundamental unit of text which is being processed by language models is called token. Token can be words, subwords, or even individual characters. So when a language model is processing text, we can measure the consumption and cost using or counting the tokens it processes. A very common unit of measurement is tokens per minute. So when you work with LLMs, you will see, or embedding models, you will see that they are providing information about processing power and consumption with this metric, tokens per minute. Okay, so we have a good basis of measuring language model performance. So how can we predict future cost based on that? And this is the complicated part, or slightly complicated part. So in our case, we started a closed beta of our chatbot, inviting 40-ish, 50-ish users, and we asked them to start talking to our chatbot. So they started generating traffic. And based on that traffic, we collected the consumption data and we collected the cost data in a certain price setup. And after that, we were able to choose the suitable subscription and the required quota for our language models. Still, you can expect some peak in the future. So there is a day when more users are interested, which is not planned. So it is practical to implement a two-layer pricing model. So in the first layer, the chatbot is working on full performance, providing full chat experience until a certain threshold. And when it reaches a hard limit, when we say, okay, this is the cost which we don't want to spend more, it can switch to the second layer. And the second layer is a low-pace setup with reduced performance, but it is operating on a much lower cost. So that's how we can protect ourselves to generate like unlimited cost or unexpected amount of cost. A few words about observability. Really don't want to go into details there because it's similar like IT systems in general. So we want to measure, log, analyze, and visualize all those aspects we are interested in. So user count, session count, returning users, use tokens, generated costs, security-related events, whatever is relevant for our team, we can add that. Quality. So when we started implementing our chatbot, quality was one of the most important aspects for us because this is the one which is directly affecting the user experience. How can we make sure we have good answer quality? So we would say let's promote only good content to production. But what is good content? So I'll come back to that later. So just to understand the basics, as we said, LLMs are working with their augmented context. So the answers are as good as the augmented context is. So how can we build a good augmented context? We need to keep measuring the chatbot experience, and we need to change the controlling factors if needed. What are those controlling factors? So it can be the system prompt, it can be the content itself, it can be the format which we use for ingesting, it can be the embedding model settings, chunking, document chunking, so a lot of factors are there. So to understand our chatbot quality, we wanted to introduce an objective measurement system, and that's how we came up with the relevance, accuracy, completeness, or RAC in short, scoring system. And we use these three numbers to measure the overall quality of our chatbot. And we can generate those numbers from two sources. First, we implemented automated tests, which are generating the RAC scores against predefined question answers. And we agreed those question answers by the knowledge owners who are providing the input for our chatbot. And that's why we consider it relevant, and basically that's the core knowledge what we want to provide. At the same time, our users are able to provide feedback with the same RAC scoring, so we can see the overall chatbot quality over time using these two metrics. So at the bottom of the slide you can see two figures. On the left one is showing the RAC scores coming from our auto tests, and the right one is showing the RAC scores from our users. They differ a bit, but that's natural because on the auto tests we are kind of using the predefined questions which are the good questions, and the user questions are the random user questions. You can imagine any user question when you are talking to a chatbot. Okay, so we have these measurements in place. That also means if we change content, then we can see how it affects the overall quality. But this process sounds a bit complicated for being manually managed. So we wanted to implement an automated knowledge pipeline. How should we start that knowledge pipeline? So we want to integrate with our document sources. I mentioned those already, which are present in Tesco, Confluence, SharePoint, Jira, our own portal, so any relevant system. And as they are different systems, the integration specifics are different as well. So we created a modular scraper framework, which is able to go to those systems and able to take the content we select. After downloading the content, we need to do some data formatting, data cleaning, because how the RAC pipeline can ingest the data, it has some specifics, and it's specific to the nature of the information. So we needed to run some ingest rounds to understand which knowledge source and which information is good at what format. Okay, so we have the document format properly, so we can upload those to the document storage. And here, let me just quickly recap on the RAG architecture. So this is the same document storage what we just added to the knowledge pipeline. So when the documents are in the document storage, the indexers kick in, the chunks and vectors will be created and added to the vector database. It means that the new knowledge is available in the chatbot. So in this case, the pre-production system contains the new knowledge. So users with the pre-production access can start testing the new content. And before it hits production, that's important. So at the same time, the automatic RAG tests are running, and users can provide the RAG scores as well. So we can see if the content is good enough. If the RAG scores are above a certain threshold over time, it means that this is a good quality content, and actually that answers the previous question, what good quality content is. So we can promote it to production. The sync job between the two systems can kick in, so contents are being uploaded to the production document score, and the same process happens there. Chunks created, added to the vector database in the production system. At this point, the new knowledge is available for all our users. So the same RAG scoring is running in production as well, which means we are keeping eye on the production answer quality. If something happens against all the safety measures we implemented, we added a version backup to the documents stored in production. So if we somehow corrupt the answer quality, then we can go back to a previous version in time when it was all good, and we can just restore that stage. All right, so just quickly summarize our learnings on the rack solution we implemented. So this is our specific rack solution. So you need to accept the non-deterministic operation, of course. You cannot expect the exact same answers all the time, and the chance for hallucination is never zero. What we can do here is minimizing those effects by the controlling factors we discussed. And the garbage in, garbage out rule stands here as well. So still we need good quality documentation to provide good quality answers. And our promise is not fixing low quality documentation in real time, but we are raising awareness on documentation quality. And it's also a promise that we provide a feedback to our knowledge owners so they can be aware when their documentation needs some improvement. And putting all these pieces together, we would like to arrive at the living documentation in Tesco, where knowledge publishers and knowledge consumers can work together in a streamlined workflow. Okay, so we have our chatbot in place. It does its job, it's working, but of course it's not completed, it's not perfect. So let's talk something about the future as well. So obviously we want to add more data and even more data. It's never enough. And at this point we are supporting textual information processing, so we would like to add image recognition and non-textual document processing capabilities as well. In a technology organization, any organization, a lot of information is stored in architecture diagrams, process flows, so that's inevitable. Based on our observations, we are working already on fine-tuning the semantic ranking and the context retrieval, so we have now enough data to see the weak points in the process, and we can work on improving those weak points. And we would like to finish implementing the automatic feedback pipeline. So now we are able to provide good feedback to our knowledge owners, but we would like to be able to do it fully automatically without any human intervention. On the technological side, so agentic AI with integrated workforce is kind of a natural choice. So you can imagine a chatbot that you can ask to create a new repository for you with all the relevant observability tooling, pipelines, and whichever is needed to be compliant with Tesco software implementation. And just some words on model context protocols. So it's becoming very popular as the new standard of integrating AI components. Adding model context protocol is kind of adding the ability of becoming part of a larger ecosystem in a plug and play way. So this is what we are thinking on at the moment.
All right, so as we approach the end of our talk, let's take a step back and reflect back to the problems I described at the beginning and assess whether we are actually moving in the right direction this time or not. So let's start with time to knowledge. So thanks to the chatbot, developers need to spend less and less time browsing through a lot of systems as we are continuously adding more knowledge, so the chatbot becomes smarter and smarter. They can just get the answers through a single system. And with that, we also reduced a bit of confusion caused by the duplicate documents and the conflicting information in the systems, because developers not just get the answers from a single source, but that source also considers their context, so we can make sure that every one of developer will get the answer tailored to their individual use case and needs. And lastly, as Csaba mentioned, by continuously covering more and more knowledge areas, we are aiming to build trust and confidence both in the knowledge owners and in the users, so the developers. Because by doing this, we want to reach a point where knowledge owners would feel confident that the chatbot will reflect their areas accurately, and also users will engage with it more and more based on their positive experiences, and also could suggest it for other colleagues so we can have a better and larger user case. So in conclusion, even though we are still in the very early stages and there's a lot of work ahead of us, we could say that based on our own measurements and on user feedback, we are started to make a difference, and we don't have any plans to stop anytime soon. So with that being said, we would like to thank you so much for your attention, and if you have any questions, feel free to ask us.
Thank you very much for your presentation. Time for the Q&A. There's time for a couple of questions. Here's the QR code that you can use for questions. We already have one. So what kind of LLM was used? Was the LLM based on any educational sources before you used it?
Okay, so we went with the commercial products available. We are using Azure AI stack actually. So any LLM which is available in Azure AI, we were choosing from those, and we arrived at using GPT-4 at the moment as the LLM, and text embedding large 3 as the embedding model.
All right, thank you. A long question coming up. So the price-related strategy you've applied suggests that the in-house bot is not running on an on-premise environment, but instead it is, at least partially, running in a third-party provider's cloud. If that is the case, why is that? Did you think about hosting it on your own infrastructure?
Yeah, that's a very good question. So yes, it's running in Azure, and it was a discussion with our principal people. There is another service in Tesco which is helping developers generating code and integrating code experience in the IDE that is running on-prem. So we had very good understanding what does it mean hosting an LLM solution on-prem. It's expensive and it's complicated. So when we started our chatbot implementation, it was kind of a, as I said, POC. That's why we picked Azure, and we still are with Azure. It can change in the future. At this point, we are in cloud.
All right. Next question. How was the vector database created, and how do you keep it up to date?
So being in Azure or using the AI stack is very convenient because Azure is abstracting all the required things for processing documents, chunking, creating the vector database, and keeping the vector database updated. So I mentioned we have this document storage. Actually, it's a blob storage in Azure, and when we upload a document or change a document or remove a document, those changes are reflected to the vector database as well. We needed to run some experience because certain indexer setups, indexer is the terminology used by Azure, certain indexer setups had not finished the implementation of keeping the vector database updated, but we arrived at the proper settings, so it's done automatically.
All right. How did you handle the new documentation, or do you have a marked date up to which the LLM was trained?
Okay, so we don't train the LLM. So we are using GPT-4, and how we add new knowledge is just through the vector database. Whatever information is added in the vector database, the RAG solution is searching for the context there, and that's how we extend the LLM knowledge. So keeping it up to date is basically updating the Azure Blob Storage with the new content, and the Azure indexers are taking care of bringing it into the database, so into the chatbot.
All right. What do you mean by completeness in RAG?
Completeness is kind of a subjective measurement of how the answer looks like. So when you ask a question and you get an answer, you can judge that you get everything in that answer you wanted. And that's why we have different scores actually on the auto tests and the user provided feedback, because the knowledge owners were focusing on creating a specific question with a specific answer, which is obviously complete, relevant, and accurate. And the interesting part is when we are receiving the same feedback from our users, because then if the completeness score is lower than the threshold for users, we consider it 2.8 on from 1 to 4 scale, then we can start investigating why is it not complete. So it's a subjective feeling basically, but we need to validate why it is that and how we can address that problem.
How smooth was the technology implementation? How many people, teams were needed to implement the pipeline and the integrations?
So when we started with the POC, we had a 4 days long hackathon week, and we just did some ClickOps in Azure, creating the very basic chatbot solution without any UI or whatever. So in Azure, you have a service called AI Foundry, which is mimicking a chatbot UI for you. With that, we created the initial version in 4 days. But that's just the playground. So making it production ready and implementing all the observability tooling and all the tooling which helps us understanding how it works and how can we improve, that is taking months. So if I can tell you the timeline, we started in January. So what I just showed, it happened since January.
Okay.
Sorry, I forgot to answer the number of engineers. The team.
Go for it.
The team consists of 7 engineers.
Okay, potentially the last question that we have time for. Have you compared your knowledge pipeline solution to existing approaches like Microsoft's 365 Copilot that could also search in Confluence, SharePoint, etc.?
Yes, but that's a bigger question than us. So Tesco's one of the most important considerations is privacy and protecting information. So as far as I know, it's still not 100% clear if we can use these cloud services with providing the full Tesco context. So that's why we started creating our own chatbot.
All right, let's do a lightning answer to the next question because we have 45 seconds left. Do you have plans to integrate with the actual code? It seems the manual documentation part still persists with the current solution. Would be nice if the model could understand the actual code, a bit like GitHub Copilot.
Absolutely. So as I mentioned, there's another service running in Tesco which is integrating to our IDE and actually our GitHub repository. And we have another possible vendor which can also generate documentation based on code. We would like to integrate that as well.
Okay, thank you very much. The question disappeared, I see. Okay, a round of applause to our speakers. Thank you, thank you, thank you, thank you. I'm sure that if your question was not answered, probably you can approach them if you're here physically and then ask it away. Thank you very much.
Thank you.